Welcome, everyone. There's more people coming. Perfect. Have a seat. This talk is going to be about what's new in C#. Everything that's been exciting about C# 8, 9, 10. Maybe we'll have some time for 11. And the next year, if I'm invited back to do this talk is going to be what used to be C# and what's now F#. Because most features in C# originate from F#. This is funny but true. My name is Filip Ekberg. It's amazing to be back here. If you have any questions after this talk, feel free to ping me on Twitter, send me an email, have a look at my Pluralsight courses. I do quite a bit of talks on C# and try to stay up to date with the language. It's definitely my favorite language on the market. And one of the reasons for it being my favorite language, the favorite language that I've ever worked with, is because it has so many great language features that let me express myself in ways that some other programming languages don't really let me do. And what's interesting with C# is that quite a few years ago now, they decided to open source the compilers. All the work of the new language features, everything that's happening in .NET and C# is being worked on in the open. This means that anyone in here could participate in discussions around language features that are coming in newer versions of C# or even F#, or things that are happening with the runtime. So over the years, there's been some changes to C# as a programming language that fundamentally change how we look at architecting our applications, how we look at expressing ourselves. Things such as generics is an obvious one that before generics in C#, we had quite nasty code to achieve the same things. But now we have a language feature that allows us to more easily express ourselves. And an even bigger one is async and await. So there are a few of these language features that change how we construct our applications and write code to solve our problems faster with less code, and hopefully the compiler lets us write code that is less error prone and ultimately makes our applications better. All right, so if we want to participate in the discussions, we can head over to GitHub and check out some of the language features that are coming in C#. This here is a snapshot of features that have already been added to the language. Some of them have been scratched from the language, which is ultimately a good thing. Because if you participate in the discussion on GitHub, why wouldn't it also mean that language features that could potentially make it into the language could also be dropped out of it? I'm not saying that Microsoft would ever remove a language feature, but if it hasn't been added yet, you might still have time to give your thoughts on that feature. I'll give an example of that later on. So before we get into everything that's new in C# 8, there's a few highlights from C# 7 that kind of sets the base for what is now a really good programming language. So in C# 7, 2.7.3, this was the first version of C# that introduced a point release. And I believe this was kind of a proof of concept that they could release a minor version of the programming language without relying heavily on Visual Studio or relying on a release of the .NET Framework or .NET Core or .NET or whatever they want to call it now. So in C# 7, they introduced this thing called tuples or tuples. And before C# 7, it was kind of tedious to have to work with tuples. This is just a container of data, or container of elements. Now, it's not obvious what item 1, 2, 3, and 4, and 5 would be in this case here. So instead, as many other programming languages, why not introduce this as a first-class citizen? So in C# 7, we have this language feature, which is called tuples or tuples, depending on how you like to pronounce that. This here constructs a container or it uses internally, it's a struct that has some fields on it, but it lets you specify one of these inline types that you can use as a return type, as an input parameter, allows you to pass this container of elements around. And you can even access the fields on that type as what their names are, which is nice. So now we have this first-class citizen in the language that allows us to work with a minimal type of not an anonymous type, but it's a type built for us using a generic value tuple behind the scenes. So this here alone in C# 7 wouldn't make much sense to use. It would let you return multiple return types or return values. But in conjunction with another language feature called pattern matching, this became quite useful. We'll look at that as well soon. In C# 7, they also introduced a concept of deconstructing an object. If I add this very magic method signature to my class, It allows me to take an instance of this class and assign it into local variables. The left-hand side looked very much like a tuple, but it's not. What happens here is that it takes an instance of my person and it deconstructs that into these two local variables, which I can then access. This, again, in C#7 wasn't something that you'd use in your everyday work, but together with pattern matching, this, again, is a really nice language feature to get. So even though we didn't have pattern matching, at this point in the language, we could look at different types of other programming languages that did pattern matching really well. And we could get that into C# as a programming language as well. If we look at these two together, they look a little bit similar. So here we have a tuple that's assigned into a local variable called coordinates. On the right-hand side, there's just two values in a container of two things, assigned into a variable that has these two fields on it. We could access them as you'd imagine. Now, where deconstruction comes into play here, and it looks a little bit different, is if I take an instance of a similar class that has this very magic method on it, I could deconstruct that into two local variables of x and y in this case. This is all due to this interesting method called here, or adding this method to the type. So these two features are quite handy, and they set the base for an important feature and important improvements made in C#8 and beyond. So with C#8, the 8th iteration of the language, you would imagine that C# at this point was done, or that you couldn't add more things. But as we see with other programming languages, we do get more and more language feature that adapts to the type of applications that we are building. More mobility means that we want to make it easier to work with asynchronous APIs, file system, I/O, network, and all of that. Pattern matching lets us express ourselves in different ways that we might not have been able to do before. So if we keep the tuples and deconstruction and all of that in the back of our heads, and now jump over to look at C#8, there's quite a few things happening in this language version. There's some minor features like read-only members, and another one called default interface methods, or default interface implementations, depending on when you looked at the GitHub page the last time. This is also the first language of C#, or the first version of C#, where it made sense to use pattern matching. While they introduced a variety of pattern matching in C#7 and built the components in the compiler to make it usable, they introduced a language feature in C#8 called switch expressions, which we're going to look at. Something called using declarations, static local functions. There's quite a few things here. Another one that's going to change the way that we build our software is nullable reference types. Completely new way of looking at reference types in C#. We'll spend some time doing that as well. And we'll look at asynchronous streams, can dispose of things asynchronously. There's ranges and indexes. So all of this here was introduced in a pretty late version of C#. And when we look at C#9, 10, 11, 12, there's going to be just as many language features, which is because many developers come from other programming languages, and we can take the best part out of that and make it a part of C# and make it feel like a C# feature. So if we want to use these and we're going to experiment with this, what do we do? Up until C#8, the language wasn't heavily dependent on which framework version you used, but there are some changes in C#8 that do require that you use one specific version of .NET. So if you want to use C#8, you'd use .NET Core 3.0. If you want to use C#9, you use .NET 5, and so forth. So this means that if the runtime and language depend on each other, they could then introduce language features that would depend on things added to the runtime, which change the language a little bit more. One of these features in C#8 is default interface implementations. It's a way to add a method body to an interface, which requires the runtime to understand what an implementation on a method means, right? So quite a few things to keep in mind here. But this is the supported structure. So it's supported to run C#10 on .NET 6. But I've had a .NET Framework project where I just enable a newer version of the language. And as long as I don't use any runtime components, the compiler will still compile code that would have worked with C#1. It's just all compiler magic, unless it depends on a newer version of the runtime. And if it does, the compiler will tell you. So that being said, we can go ahead and create different projects depending on which type of runtime we're using. Since, for example, here I have a .NET framework project for WPF, but I can also create a WPF application which is now targeting .NET 6. That doesn't mean that it's now cross-platform. Everything that's happening in .NET and with Framework Core, the new .NET and all of that, it's a totally different topic on its own. But going forward, it's one thing. So I can use the language features of C# 8, 9, 10, 11, and all of that in WinForms and WPF. It just means that I have to port that over to this new project structure, but doesn't mean that WPF and WinForms is now cross-platform. There's other projects to allow you to do that. So if we create a shared library, or if we enable a newer version of the language in an older project, and the compiler deems that, well, you're targeting a runtime where this doesn't work, it will tell you. It will tell you that you're targeting something that's not allowed. So even though I can use some C# 8 features in .NET Framework 2.0, for example, it will tell you if you're doing something you shouldn't. This particular example here is using something called default interface methods or implementations. This language feature, depending on who you are, either you really hate this language feature or you just don't like it. Sorry. So this is interesting. Let's say we have this interface. We have this iCache here, super simple. It exposes a non-generic version of grabbing something out of a cache. Let's say that I want to update this. This is a very popular NuGet package. Someone pulls this down all the time and uses this. And what happens if I want to add a method to this? That means I'm going to piss everyone off that uses this interface, because now they have to implement this. That means I can now introduce a method body on my interfaces. So I don't have to force anyone to implement this, which can be seen as a good thing. For library developers, this is really useful. It means that I can update my libraries, I can update my interfaces, which I use internally myself, but I don't have to force anyone else to actually implement this themselves. But the problem here is that the compiler and Visual Studio won't tell you that you have to implement this yourself. The compilers and all of that will see that there's already an implementation in the interface. So if you update to the newer version of the interface, there's no warning or anything like that, which would be very handy. So I wouldn't know that I have to do this. So anyone going to use this? One person. Excellent. We'll have a talk later. I want to know why. Maybe you're a library developer. It's really good if you're doing libraries. Now, another feature introduced in C# 8, which, again, is useful. This here, you could use this if you want to, if you're a library developer. But where C# 8 introduced something that will change how we look at building software is nullable reference types. So up until now, everyone that's used C# knows that a reference type, a string, a class, an instance of a class, it's a reference. It can be set to null, which makes sense. But how about we would like to remove nulls from the language? Because nulls is a problem. Who hasn't gotten a null reference exception? You're lying. I know you are. Everyone's going to experience this at one point or another. So nullability is a problem for quite a few reasons. And how about we tell the compiler to look at nulls in C# a little bit differently? How about we indicate that I really don't want to use nulls anywhere, and if I do, you're going to smack me on my fingers. And I have to be explicit about the places where I'd like to use this. Now, before we look at how to enable this, the problem with nullability is that it clutters my code with a lot of null checks all over the place. And another issue with that is there's many different ways to perform null checks. We can use null conditional operators. There's if statements. There's argument null exception or throw if null. There's a lot of different ways to throw an exception or find nulls. So that's going to make the code harder to read. But it's ambiguous. What does it actually mean to return null out of a method? Let's say that I have a repository to find a person or find a user. If that returns null, does that mean that the database connection was closed? Does it mean that I couldn't find a user? I know that personally. I do a Pokemon try-catch-all. And I just return null out of all of my methods, and then no one knows what actually happens. There's better ways to architect your software, so don't do that. It also encourages mutability, which is a problem for multi-threaded applications. If we can set things to null, that means that at one point or another, we'd like to change that to an actual value. And in multi-threaded applications, that's a problem, because you don't want to be able to touch objects from different threads. So how do we solve this? This here is quite ugly, and I know someone here is going to say, you can write this in many different ways. Surely enough, we could simplify this a bit, but still, I'm not particularly fond of having to add this if this would never have been an issue. Instead of having to perform these null checks all over the place, how about I tell the compiler to let me know if this could have been a problem? And I can do that by enabling a feature called nullable reference types. This is the default in .NET 6 and going forward. So if you create a new project, this is going to be enabled. You can enable this for a method. You can enable it for one line of code, for a class, for a namespace. You can enable it for an entire project. I don't believe there's a setting for an entire solution, but you'll just enable it per project. What this here is going to do now is going to change how the compiler looks at these different reference types. So in this case here, well, it's obvious that it's null here, but we get a little bit of squiggly here telling us that name may be null, which is really handy. And together with this, there's another thing that we also can do, because this is just a warning. The compiler is going to tell us as well, you should probably attend to this and fix this. How many of you are actually looking at the warnings in Visual Studio? I bet you're lying. I'm just kidding. So 50-50. I'm one of those developers that have a million warnings in my solutions, and I'm like, oh, I'll just look at that later. I'll add a to-do here. I'll fix this tomorrow, and then I never do. So the problem here is that if this is just a warning, 50% of the developers might not actually fix this, and 50% will. So what do we do then? We turn on warnings as errors, which is a great feature. We can then say that whenever there's a potential null reference exception, we're going to have a compiler error instead. So what I suggest is that we go into Visual Studio, and we have a look at how we enable this. I'll go in here, and this solution here, I haven't enabled this feature yet. But what this is here, just full screen this, there's no warnings, there's no errors, there's nothing like that. There's nothing here that looks like it's potentially a problem. Just normal classes, and inside my program here, I'm just using these different things. But I know that if I run this application, I'm going to run into a null reference exception. But I'd like the compiler to tell me that this could be a problem. So I'm going to go over to either we do this from the normal project properties. We could do that. Or we can go into the csproj, and we can indicate here that we want to enable nullable reference types. Here we go. And I'm also going to turn on treat warnings as errors. So I suggest that everyone here enable, here we go. I suggest that everyone go ahead and go back to your work, enable nullable reference types, and also treat warnings as errors. And then you check in the code, and then you go home. Let someone else fix the problems. Don't do that. Don't tell anyone I said that. So now I can click down here and see that, well, now I have a few different problems. Now I have 4 errors that I should probably attend to. And if I scroll through the code here, I'll see here that there's a warning here, or an error in this case, that's telling me that this property should be set to a value. It's not initialized. I could fix this. There's multiple ways to do this. I could introduce a constructor. If I introduce a constructor, the error moves from the properties to the constructors, because now it should be the constructor that is in charge of setting these to a proper value. This means that I should probably take first name and string last name as a parameter here, and I should set these to their appropriate values. And if I do, the warning is now, or the error is now disappearing. But the problem here is that I've now changed the contract of my class. Everyone that's now using this here, if you were to do this at work, you would change how everyone instantiates this class, which is, again, not really a good thing. But if we remove that again, there's another way that we can approach this. This is not really where the null reference exception would have occurred, right? There's nothing in here that accesses a property. The null reference exception would have occurred where the first name and last name is being used. So to figure out where that would be a problem, I could indicate that this is a nullable string, and this question marks work with everything. You've seen this with nullable value types before. But now we have a nullable reference type. So I can say here that, well, now string can be set to null, which is fine. And I'll do the same in my person class, which is using this reference type. So now these no longer have any warnings. All right, so then hopefully somewhere else in the application, there's now an error or a problem where I would use this. And look at that. The compiler now figures out that person.details here might not be set to an instance because I've indicated to the compiler that this might be null. This means I'd have to perform a null check. So if person is an object, we can do this. Or it's not null. Oh, sorry. I'm going to write this as confusing as possible just to show you how pattern matching works. So don't do that. Instead, do person.details is not null. And that would also work. So the compiler figures out that I've now performed a null check. This is called null state static analysis. And it is smarter as well because I could also say if this is null, I'm going to return or continue to the next one. And it just knows that I've performed the null check one step above. So it tracks that I've actually checked this, right? So this is cool. It works very well with pattern matching. It's going to work with normal is not or it's not equal to null as well. But it also works with things like we all normally use, string.is null or empty. Oh, sorry. If we do this, it would have worked with that. Just trust me. I'll show you. So let's say we access length here on that, and we do first name. It would be smart enough to understand that I performed a null check on that entire expression as well. Because it's null or empty has some magic attributes set on it, so it understands that I performed a null check on the variable that I passed into the method call. So the compiler is doing a lot of really clever things here to try and track the null state of our variables. This is super handy. But then again, this here doesn't look very beautiful, so I'm not going to do that. But this here is showing you that we could track that this would be a problem. But in this case, maybe I don't just want to perform a null check. I can do the null conditional operator to check that, well, maybe we just want to get that value if it's not null. What I can also do, if I remove that again, you'll see that we have a warning. I could also use a null forgiving operator or the dammit operator to say, well, I've performed a null check. The compiler is just stupid enough to don't understand what I want. This is rarely a good idea because the compiler is not stupid. I'll show you why. So let's say that I have a person here. Person is equal to null. Person2 is equal to null. It's going to give me a warning here or an error saying that this is null, but I can tell the compiler that I'm smarter than you. And, well, it's also, we'll just get rid of that one as well. Person2 dot first name. Here we go. So I could have told the compiler, just complain that I didn't use the variable. So I could have told the compiler that I know better than you. I know that I've performed a null check on null, and it's not null. This isn't going to throw any exceptions. It's not going to be a problem during runtime unless you actually try to access something. Unless I try to do this. This here would blow up, right? Because this here is now a null reference exception. We can obviously see that. So we are not smarter than the compiler. The only reason you'd ever do this is if you are setting something to a default value down here at the bottom. For example, if I were to do this, and I want to set this to a default value, and I want to promise or just say that I forgive that this is set, then the warning goes away again. And whenever someone sets this property to a value, it cannot be null. But I'm going to default it to null if you haven't set it. So it's a little bit confusing, but the only place you'd ever use the null forgiving operator is with the default keyword. Just keep that in the back of your head. So again, This here was quite clever, and this here is a really great language feature. But there's one more place where this is a problem. In this case here, I'm returning a nullable list, or I'm saying that I want to return null where I have an IEnumerable. I could say that I could return a null list, or a null list of potentially null people as well. So you get the idea. You can use the question marks to indicate to the compiler that something could be null or not null. But in this case here, I'm going to show you a little bit of a trick, because what we want to do here is that we want to yield return a new person. And we want to set the details to a new object with some first name, set to Filip, for example. This here is called the target type new expression. I don't have to explicitly say which type I'm creating, and I'm using yield return to just build a list for me, so whenever someone's trying to iterate this, it's going to allow me to do that very nicely. So this here is quite handy, and it's a really nice language feature, in my opinion, to be able to find these potential null reference exceptions before they occur. The whole idea is that it gives us a little bit of help. It's not going to just magically solve all your problems, but it is going to let you now find things that could potentially throw an exception. All right. So in my opinion, this here is truly a great thing to enable, at least for new projects. So do this only enable treat warnings as errors if it's a really completely new project, or you know that you don't have any warnings. Because doing this, enabling this on a large solution can be a little bit annoying. People will get pissed off. So with that being said, let's talk about another important language feature that was introduced in C#. It's called asynchronous streams. And this requires that you understand a little bit of asynchronous programming. So imagine that we want to fetch some data, and we want to get item by item. Each item is retrieved asynchronously. So it could be something that's loaded from disk. It could be a buffer that we're loading something from. But we want to grab the element, process that before we go ahead and get the next one. To produce one of these streams of data, we introduce the async keyword together with something called an iasync enumerable. This here indicates what type of data will be streamed back to whoever is consuming this stream of elements. So I could say that this here is going to produce strings as it goes on. All right? And where the magic happens is with the yield keyword that I just showed you. So this here will now indicate to whoever's iterating through this asynchronous list of items that there's a new element to process. Each element is going to be retrieved using the async and await keywords. Here I'm opening a stream to a file on disk. And then what I'm doing is that I have the await keyword here to say that I'm going to retrieve this asynchronously. While my file system is very fast, I'm going to say that, hey, I'm doing some processing using task.delay. And then I can consume this very easily using a for each loop. Let me go into Visual Studio Code and show you how this works. So we're going to sort of do the same thing. Here, I have a method marked as async using the iasync enumerable. This here is going to produce strings. Each string is going to be retrieved in some asynchronous manner. Imagine this could have been listening for items or producing items from a queue in Azure, for example. But here, I just have a using declaration. What's interesting here as well is that this stream will be disposed of when the stream no longer produces any more items. So after this entire stream has been processed, it could be forever, right? So this here could hold on to the file until the application terminates. And then what I have here is I have a while loop to say that I want you to read the next line of the file as long as that is an instance of a string. It's using pattern matching to ensure that it's actually set to it's not null. And then I'm going to declare that into a local variable, which I can use inside my while loop. And then I have a task.delay, and I return this line of text back to whoever's consuming this. Rather simple. This here is just illustrating how we could produce one of these streams of data. What you most of the time do is you're on the consumer side of things. Look at that. We have the await keyword in front of a for each loop. Normally, when you use async and await, you have something that looks like this here. But what this indicates is that we are going to get this entire chunk of data in one go, and then we're going to run through that. What this means, await for each, means that each item, we're going to go into this body one by one as you've retrieved an item. This here is what you would most of the time use. Maybe you don't produce a stream of data as frequently as you use one. Another good example of use case here is that I could be listening for items on a queue. There's a service bus client for Azure, so you could say that, hey, I want to listen for the next item available in a service queue, and that would use this stream of data as well, or this asynchronous stream. So now each line will be retrieved asynchronously. So if I run this, let's zoom in here and do .NET run. It's going to read a file and then print out each line one by one of my favorite song. Hopefully this works. If you don't know the song, welcome to the internet. All right, so this is pretty cool. This could have been then streaming data from pretty much any place. It's a very nice way of consuming data where you don't have to load the whole chunk into memory at once, but one by one you're retrieving them, right? So it won't call this line of code here until the for each loop has processed the previous element. So it calls get next on the iterator, and then it goes ahead and queries for the next one. Pretty simple, but very useful. All right. So again, we could have used this to very easily consume an iasync enumerable. And while many APIs haven't adapted this yet, it's going to be very much adopted in the next few years, I do believe. Just as async and await is still something that a lot of developers struggle with and haven't really added to their solutions all over the place, I do believe this is also going to take some time to get traction. So with that being said, C#8 introduced a lot of interesting concepts, but C#9 did so too. There's a thing called records, which was, they talked about this even way back with C#6 and proof of concept, a thing called primary constructors. But that was a long time ago and took a while to get around building this feature. Records is a shorthand way of creating a reference type that gives you value-based equality and gives you immutability out of the box. It's coupled with something called an init-only setter, so you get a true read-only auto property. Top-level statements, it's what I just used inside my program.cs. It's a completely new way of producing small applications. You can use it to create APIs, to do an ASP.NET Core website with just 10 lines of code, for example. It's very, very, very powerful. And we're going to look at all of the pattern matching enhancements as well, both in C#8, 9, and some of them in 10. Target type new expression I showed you, that's from C#9. And there's a whole lot of features in C#9 that was also introduced. Like, it's kind of interesting how you can add so many features into a 9th iteration of a language, right? Some of these are targeting very high performance applications, lower level programming. But again, it's interesting to see that because of the open source of the compilers, I believe that it was easier to add more feature to the language. I'm not saying that every project should be rebuilt every 20 years, even though we all probably want to. This proved that that was a really good choice. So with that being said, we're going to spend some time talking about the pattern matching in C#8, C#9, C#10, and going forward as well. Pattern matching is all about being able to, in this case here, look at different traits of an object, for example. I have a puzzle piece. I have this IKEA poster. I could be looking at colors, shapes. I could be asking, is this fruit edible? There's many things that we could check on an instance of an object or what a thing is. I talk about matching on the type as well as the attribute of the object. Not in terms of the attribute you put in the brackets atop a method call or a class, but in terms of what color is it edible and those types of attributes. We've always been able to do this. In C#1 to C#6, for example, you would have written some code that looks like this here. If the fruit is of a particular type, and the color is what we're looking for, imagine if the color was actually on the subtype, this would have been much more complex. And we've all written code like this here. It's nothing wrong with this. It's just a little bit more noisy than it has to be. So that's why in C#7 they introduced pattern matching, which makes this a whole lot easier, which is a lot more noisier than the first one. So the reason that we didn't see a lot of pattern matching in C#7 is because it relied on using the switch. We could have used it a little bit with the if statement as well, but no one did at this point. So this is sort of doing the same thing. It's grabbing the instance of our type, it's matching a particular type, And then over here, let me put on the laser pointer here. Then over here, it's actually capturing this instance as the correct type. So inside this when clause here, while I could look at properties with computed values, it would be able to use this as the concrete type. I don't have to do any casting myself. It all just is done by the compiler, which you would expect as well. So now in C#8, they introduced the switch expression. And in C#9, they added a whole lot of expressions that we could use, or a whole lot of patterns that we can use with this here. This looks a little bit different. But if you've ever done Kotlin, Swift, or other programming languages that have had pattern matching for a long time, you'll be familiar with this, or if you've done F#. So what this is doing here is that it's saying, I want you to create patterns for this object. So based on the input, I want to produce a result. On the left-hand side, we have what's produced out of this here. We can fill this with expressions together with patterns. So here's a concrete example of that. I can say that based on a fruit, if it's an apple, we return a string. This here is the same as doing an expression-bodied member. It returns that data. This here is a discard. It means that I don't care. It could be null. It could be any object, as long as they're all relatable. If this here was an object, as in the type object, you could have matched on pretty much anything here. So again, this is what's returned out of this switch expression. And we're going to spend some time looking at, we've seen the type pattern. I used this in the while loop where I said it has to be a string. There's also a positional pattern, which we're going to look at as well, which is used with this deconstruct method as well as tuples. There's property patterns, tuple patterns, relational patterns. You can append them together with an and or conjunctive and pattern. There's the disjunctive or pattern, parenthesized pattern, negated patterns, recursive patterns. It's a whole lot of patterns, right? Instead of just talking about them, let's go into Visual Studio and have a look. And you'll notice that as C# is evolving, there's going to be more patterns added to the language. And the whole reason is that we want to make it easier, or the language designers do want to make it easier for us to express ourselves in ways that was maybe a little bit more tedious before. So let's say that I have an instance of, I have a type here, or rather it's a record. There's a few things happening in this class here, or this file. I have 3 record types. Now, these are all reference types. They are generating classes behind the scenes. They give me value-based equality. They give me some deconstruct methods out of the box. And they also come with something called a primary constructor. So here, for a failed test, it takes the amount of tests or amount of attempts, the date that I performed my university test, for example, or a computer test, and pass these up to a default or the constructor of the base class. The base class looks like this. So it has a primary constructor, again, that has these required parameters. When I create a test result, I'm required to pass these parameters, which is quite handy. Another example of a record, before we look at the pattern matching, is if I can run this here. I've simply built this record of a person, has a first name and last name. I'm instantiating that here. The constructor requires me to pass these parameters, and after that, it's immutable. I can't do any changes to this object at all. And this here on the left-hand side, I'll zoom out a little bit just to give you an idea of all the code that's generated. So we have the backing fields, and then if we scroll down a bit, there's quite a bit of code generated out of this here. It's a class. It has a nice toString method. It lets you print this as a nice representation. It overrides equality check to give you value-based equality. Value-based equality is where it compares the properties instead of the instance or the reference, which is why you cannot use this with Entity Framework, because Entity Framework relies on reference-based equality checks. With that being said, it also comes with a deconstruct method down here at the bottom. This will deconstruct it into whatever you want with these properties that you require on the record. So with that being said, I've also added my own. So you can have a record here with a body. So I've introduced a primary constructor. It generates sort of the same code we just saw in SharpLab, but I've also added my own deconstruct method. So it doesn't have to give you the same properties that you have on your type. It can be computed values. It can be whatever you want. So why is this important? Now, let's create an instance of this test result. We're required to bring in my namespace. And I'll say result, or test result, rather, is equal to a new failed. Now, this here requires me to pass the number of attempts and the date time offset. Let's just say now. Perfect. Looks like a normal instantiation. Now, what I can do here is that I want to get a string representation of this, or it could be that I want to return a user to a specific place, but depending on what type of result they got. So it doesn't have to be a string that you return out of your switch expression. But I'm going to, so I'm going to say var outcome, rather. Outcome is equal to, based on this test result, I'll create one of these switch expressions. This here is now filled with expressions. Now, it's going to complain that I haven't added any yet, so I can start off with, if I can spell nope. Can't spell inconclusive. So let's just do nope here. So that's for all other tests than the ones that I'm looking for. This here is a default pattern or a discard, so it grabs everything. I could also say that I want to grab the result. Let's do result here. That this will do the exact same thing. So if you use the var pattern, which this is called, it would match on nulls. So I could use this over here. It wouldn't be useful if it actually gives me null, but I could access this as a test result because it could be any other test results than the ones that I'm looking for. So let's say that I want to get the test state here, but again, this here will match on anything. It could be a null. So I would have to do my null checks here as well. All right, so we have that. Now, I mentioned the deconstruct quite a few times, and I could use that here as well. So the deconstruct can be used together with what's known as a positional pattern. I know that one of these test results, it has a deconstruct that gives me 3 values. The date of test, how many days ago this was, and if the test is now archived for some reason. So I'd like to write a pattern that looks at what this object can be deconstructed into. I can say that I don't care about the first value. And the second one, this is why it's hard, because I have to go back and forth between the code when I write these tests. So let's say it's more than 10 days ago, and I don't care about if it's archived. How many of you think this makes sense? A couple? Wow. So when you come back to this code tomorrow, you'll have no idea what this actually means, right? This here is a relational pattern. It's saying that whatever this object was deconstructed to, the second position of that deconstruct has to be more than 10. I have no idea what that was. I'll have to go back again. I could use a name parameter here. But again, I'd very much like it if Visual Studio told me what it deconstructed into by looking at the parameters. Maybe it will in a future version. This makes more sense. But I still don't know what it is that I don't care about, so I'd have to add that here as well. What's interesting here is that this here will look at all of the different subclasses as well, because this lives on the base class. So as long as any subclass can be deconstructed into this, this will be a match. But I could also say that I want to be more specific, because since I don't believe this makes a lot of sense, because you have to go back and forth and actually own the code and look at it, or inspect the code with something else, or go into the definition, I'd much rather say, well, if it's failed, and I can capture this inside my switch here, or inside my block here, and say, sorry, you failed. And I can use this with a string interpolation if I want to, and I can access this here, as you'll see, as the concrete type as well. So I could capture this into this the right-hand side of my expression here. I could also say that, well, I want to only get failed tests that have a number of attempts more than 2. Right? So this here is starting to make a little bit more sense. If I were to remove the type here, that would mean any test result. So the base class, a positive, a negative. But I can say that it has to be failed, and it has to have a property. This here is a property pattern. So using the curly braces, or curly brackets, I can say that I want to look at one of the properties. Again, using this relational pattern. It has to be more than 2 and less than 10, for example. So I can use conjunctive ands to put different types of requirements together. This here allows me to now define a range of allowed values, for example. This isn't only useful inside a switch expression. So we could fill this up with a lot of other ones as well, right? So it's passed. I could do that as well. So you get the idea. You can use this, all of these different patterns together. It doesn't have to have the same type of patterns. So here's a type pattern. Here's a type pattern with a property pattern, with a conjunctive and pattern. Since it's using more than one, it's going to be recursive. And then it's using the deconstruct. So you can combine these together to write very hard to understand code. Or you use it to write understandable code. So you can use this with the switch expression, but you can also use it with a normal if. So I could say, well, if the test result is passed, and it has a test state, or its number of tests is probably easier, and we can relate that to, let's say, more than 10, then I could use that inside this here. And if I want to grab this, before I do that, what do you think happens if I negate this entire thing? Again, it's very confusing, right? I have no idea, actually, without running the code or running tests for it. Be careful when using not. Not is really good for negating an entire pattern, but it's mostly useful with not null, for example, where you negate that it's null. All right, let me just go back here. If I want to capture this here inside this if statement, normally what you'd have to do is say var passed is equal to test result as a passed test. Now, we don't have to do this. We can take this variable declaration and put it over here at the end of the if, and we'll have this inside our if statement. Extremely useful. And I don't have to do any casting myself. It's now the concrete type of what I'm expecting. So pattern matching and the record types are extremely useful, and it's being continuously worked on by adding more patterns, more ways of looking at instances, properties, lists, contents, and all of that, just to make it easier to express ourselves. One way to look at this is using, for example, an option or a maybe, to say that maybe this returns an object, or maybe it returns a positive result. Maybe it was unauthorized. Maybe it was a successful attempt. And you can use this to determine where you want a user to be passed on to for a website example. All right. So we have a few more things that I want to go through before I'm actually done. So this is all the patterns that we have in C# so far, which is quite a lot. Whoops. And I'm not going to suggest that you just know all of them from the top of your head. The tuple pattern looks very similar to the positional pattern. It's just that instead of us having an object that is deconstructed, it looks at a tuple as an input. But you can experiment with that on your own. So C#10 introduces another way of producing a record. You can use a record struct, depending on where you want that to be located. Now, I said that record classes are mutable. Record structs are not. You have to append the read-only keyword if you're doing a record struct. Otherwise, it won't be read-only, or otherwise it won't be immutable. There do some improvements. They have global using directives. So we could say that we have globally introduces something that we're using in our entire application. It's a file scope namespace, extending the property patterns. They're improving the lambda expressions, or have done, constant in interpolated strings. And there's quite a few things happening in here. Let me actually show you that file scope namespace declaration. I've used it in the example that I had here, but it might have been subtle. So at the top here, I have this namespace declaration. This here says that this entire class now lives inside this namespace called NDC. Might seem silly. Why can't we just have it inside this nested block here? But, you know, unnecessary characters passed into codebase or into GitHub is a little bit unnecessary. All that white space is annoying. So we can just do a semicolon here, and it should just figure that out and remove that level of indentation. And the record structs would look like this. So instead of having a record class, the record keyword defaults to a record class, but we could do record struct. If we wanted read-only, we'd do read-only. Actually, read-only record struct, like this. Might look a little bit confusing, but for those of you that do need value types, this is very, very handy. All right. So C#10, again, introduces quite a few things. And one of these is, of course, I mentioned this quickly, it's a constant in interpolated strings. What this allows us to do is then use constant values in interpolated strings, which we couldn't do before. But more useful, I'd use this, but another more useful feature is inferring the delegate types of a lambda. So this is C#9, and this here requires us to explicitly tell it which type of lambda this is, or delegate this is, which seems unnecessary, because the compiler should be able to figure this out. And it can, in C#10, we do get this out of the box. So it tries its best to figure it out, but depending on the input, or what it has on the right-hand side. But it would also be able to figure out, for example, if we had the func string of int parse, we could remove the string from the anonymous method. Make sense? It's a handy feature. It tries its best to figure things out for us. Probably one of my favorite features is, with these top-level statements, is to build minimal APIs. And a minimal API can look like this here. This here maps the path /id to whatever this anonymous method returns. And now, with C#10, we can have attributes in our lambdas, which again is quite handy. It means that we can produce pretty powerful minimalistic APIs that we can pass as a part of a larger application, or we can do it as a very much smaller standalone application as well. So we all know that minimal APIs or microservices has been a thing for a very long time, but now with this concept, hopefully the micro is actually going to stay micro and not grow out of proportion like it normally does in a microservice. All right, so what's next? We have about 8 minutes to cover everything else that's happening in C# for the next 10 years. I'm kidding. There's quite a lot happening to C#. The reason I still love C# and still talk about C# is because the language is evolving, and it's evolving in a way that it feels like every feature in the language is still something that could have been a part of C# from day one. It feels like it belongs in the language, and it makes it easier for anyone that's starting with C# to understand how all of the features work. But then again, they're going to add more things, and hopefully all of these are going to feel like they belong in C# as well. So with C#11, was a whole talk yesterday, I believe, on C#11 and all of its features. So there's quite a lot happening in the language, and it's going to continue that way as well. There's going to be more patterns. A pattern of C# is to introduce more patterns. It's going to be a way for you to look at the contents of a list, for example, to match on the content that you expect to what you get. The name of operator, you'll be able to say name of parameter instead of passing the type. It's finally going to cache the delegates for static method groups, which is a huge performance improvement. There's this thing called required properties. So before, I had to write some quite nasty code to get around the problem of I didn't want to introduce a constructor when I enabled the nullable reference types. But I still want to require people to set my properties to a value. That's why we could say, I require you to set this property called name here. It shouldn't be null, but you're required to set it. And you do that in the object initializer. And here you see the init only keyword. That makes it immutable, or it makes it, you can only set it once. Right? So after you're required to set it, you cannot change it without getting a new instance. All right, then we have something called raw string literals, static members and interfaces. I believe I have a slide on that soon. And then UTF-8 string literals. This is a really nice language feature. It allows you to say that I have a string, and I want to use that as a span of bytes. Working with spans is a whole topic on its own. It's a really interesting type that lets you work with unmanaged, managed, and all types of different memory in your applications. So here I can say that I have this string here, it's allocated in memory, and I'm going to use this span to say that I can substring this, I can find portions in it, I can slice it off without having to do any extra allocations. And they've done a lot of work with this and used it internally in .NET, and it's speeding things up quite heavily. I know ASP.NET uses this a lot, and there's some performance benchmarks on how great it is to do this. Because you can pass memory around, and you can slice it off and work with portions without having to allocate any extra memory at all. It's like working with pointers in old C and C++. Super useful, but without the problems of pointers, that is. Also going to get generic attributes, which is a very nice addition. I've been wanting this since probably the day I started using ASP.NET. Being able to do a generic attribute on a controller, for example, super handy. I have no idea why it took 20 years to build this, because it's an amazing, well, since C#2, that is. Now, there's another language feature called parameter null checking. It's a double bangs. So if we were to add double bangs to a parameter on a method, it would automatically add argument null exception dot throw if null. But it seems like no one liked that. Let's see here. So apparently some auto-generated code is fine, but others isn't. So what the feature was, I believe, double bangs like this here, and it would automatically null check this for you and throw an exception if the input was null. Unfortunately, no one liked it. I did. I liked it. But then, of course, they remove it from the language. Based on community feedback, that is. Let's go back here. So there was a lot of backlash on that feature, so they removed it out of the language, which proves that doing this open source and getting some feedback from the community is great, because we can all participate and give them our opinion. We all love opinions when working with software. Now, what's unfortunate with this is that some teams also doing open source at Microsoft, like the ASP.NET team, they had already refactored their entire code base to use this. I do feel for them. Like, that must have been quite bad. Anyways, here's another one. Before we end this, there's this thing called static abstract members in interfaces. If we were to do this today, there wouldn't be any compiler problems. It wouldn't tell us that I have this static T on my interface I singleton. We all love singletons, and if you're from Java, we all love this. So, but it's not telling me that my actual person class here should implement that, right? Which is a little bit problematic. So now with C#11, this here is a preview feature, but if we do static abstract, it would then indicate that the person class actually has to implement the interface, which I would have thought it would do without that abstract keyword. But this is a preview feature, and hopefully it's going to make it into the language. Not all of us does singletons or singletons, but this here does going to tell us that this doesn't implement that. So with that being said, there's quite a lot happening with C# as a programming language. And going forward, I do believe that there's going to be much more features added to the language, which as developers that have been working with C# for a long time can be a little bit confusing. And it can be hard to keep up with all of the language features that are added. But tools like ReSharper and tools like Writer and tools like everything else that comes in Visual Studio in terms of refactoring is going to try and help us to write our code more effectively and efficiently to make it also more readable. Like, we want the compiler to help us write better code, not just write code that's faster. Like we saw with pattern matching, we can write code that's really hard to understand and read, but ultimately we want to write code that's easier to maybe show someone in the business, because we all want opinions on our code from the business side of things. But if we can show them that, hey, I translated this criteria into a pattern, it makes it easier to talk the same language. And I think that's important. So with that being said, I have a lot of things on Pluralsight. I have a lot of courses on C# and Python and all kinds of things. Check that out if you like my stuff. And it's been a pleasure being back. I hope to see you again next year. So thank you so much for coming along.